Now can you hear? Okay, can you hear? P is a linear momentum, m is a mass, is a vector scalar quantity, and velocity is a vector quantity. Okay, thank you. I think that is not here. Okay, fine. Thank you. Right, start. V is a velocity, vector quantity, mass is a scalar quantity, P is a vector quantity, linear momentum. How can we say? Means when a vector is multiplied with a scalar here, we get again vector. When a vector is multiplied with a scalar, again we get a vector here. Means I'll tell you one example here. Now I is a velocity. A body of 5 kg, body of mass 5 kg, moving with a velocity 2I, moving with a velocity 2I. What is its linear momentum? What is its linear momentum? Means as you know, linear momentum means mass into velocity. What is the mass? 5. 5 into 2I. 5 into 2I, how much will you get? 10I. What is it? 10I. Correct? This 10I. See here, again I am having the direction. What does this I represent? Along x-axis. Okay, na? What does its I represent? Along x-axis. Okay? Along x-axis. So this is 10I, means along x-axis. Means we can give the direction for this. Velocity is along x-axis and linear momentum also we are getting in the direction of x-axis only. Got it here? Means what I conclude here is when a vector is multiplied with a scalar, you will get a vector itself. When a vector is multiplied with a scalar, we will get a vector itself here. Okay, na? When a vector is multiplied with a scalar, we will get vector itself here. Means when a vector is multiplied with a scalar, we get vector. So linear momentum is also a vector quantity. What is it? Linear momentum is also a vector quantity. Got it? So if you see the units for this linear momentum, we can see here the formula for this, how we define this linear momentum is, it's a product of mass and velocity. It's a product of mass and velocity. Okay now? So what I am discussing here is linear momentum is a scalar, is a vector quantity. The one expression I can say is a vector quantity. What is the direction? This direction will be in the direction of velocity only. If velocity is along x-axis, linear momentum also along x-axis. If velocity is along y-axis, linear momentum also along y-axis only. If velocity is in this direction, velocity is in this direction, is linear momentum also in the same direction. In the same direction. Got it here? So linear momentum and linear velocity will be, or both will be in the same direction. What is that? In the same direction. Means momentum is a vector quantity, right? And coming to the units, what are the units for this? What are the units? The unit for this is mass unit kg. Velocity unit meter per second. Meter per second. So the linear momentum units becomes kg meter per second. What is it? Kg meter per second. Got it here? These are SI units I can say. These are SI units here. Means or MKS unit also, no problem. And next we have a CGS. CGS instance, 1 kg is equal how many grams? 1000 grams. Or wait, I'll tell you one thing. And the CGS units are gram centimeter per second. What's it? Gram centimeter per second are the units for this. Understood here? What is linear momentum? Linear momentum is the product of mass and velocity. Linear momentum is a vector quantity. Okay? Units are kg meter per second. Understood here? Kg meter per second. Linear momentum is kg meter per second is a unit. And this is the SI units, whereas here it is MK unit here. What is it? Gram centimeter per second. No need of by hearting the units. Some of you may not know the velocity units also. If you don't know the velocity units, I'll tell you how to do. Velocity means displacement by time. What is it? Displacement by time. Velocity unit is displacement by time. If you check here, displacement is meter and time is second. So the units becomes meter per second is a unit. Try to learn the basic things in this way. It will be very easy for us. Okay, na? Velocity basic formula we have to know here. Rate of change of displacement, or simply we can get displacement by time also. Displacement time is meter per second. This is the velocity units. Velocity units. Got it? Right. So therefore, I can get the linear momentum units as kg meter per second. Okay, na? So in this way, we can get the units for this. This is the linear momentum. Linear momentum is a scalar quantity, vector quantity, and the units are this and this. Commonly, the vector unit quantities we have to represent like this: p bar, like this. Okay, na? So that's what. Okay, fine. Here we have to know one more point. Change in linear momentum. What is it? Change in linear. We commonly write there indicates dp. dp indicates a change in linear momentum. What is it? Change in linear momentum. Change in linear momentum commonly we go for final momentum minus initial momentum. What is it? Final momentum minus initial momentum is the change in linear momentum. Commonly, if I am writing this dp, then it's very big changes. What is it? Big changes. For small changes, we commonly write this one as a small dp. How much we get? Small dp. dp and capital. This is dp or delta p also, no problem. Sorry, delta p. Delta p also represents a changes itself. dp I'm writing here means it's a change. Okay, if the momentum velocity is going, you are going on a bike. Your speed is going to be changed, right? Your velocity is going to be changed. When velocity changes, automatically linear momentum also changes. The change in momentum is commonly mentioned as dp. Okay, change in linear momentum is final minus. Generally, we go for change in final minus initial. Okay, final minus initial. Generally, we go for the final minus initial. Okay, so these are the basic dp. Next, now I'm going to see, let's consider, I'm going to take let's consider, a body is moving of mass m, moving with a velocity u, okay, and after some time, its mass becomes v. After some time, its mass becomes v. What is the change in linear momentum? Change in linear momentum means final momentum minus initial momentum. Final, what is final? This is the final momentum. The final momentum is m into v. Understood? Final momentum is m into v. And coming to this, initial momentum is m into u. Because u is the initial velocity, v is the final velocity. Final. Now, if you check this one here, m into v minus m into u. So, this is a change in momentum. What is it? Change in momentum. m into v minus u is a change in momentum. Understood? Here I am taking an example that a block of a body of mass m moving with a velocity u, and after some time its velocity becomes v. What is the change in momentum? Means final momentum minus initial momentum. What is the final momentum? Mass into final velocity. Whereas initial momentum is mass into initial velocity. Okay, na? So in this way we have to find the change in momentum. We will take 1 or 2 or 3 examples for this for easy understanding. Okay, na? I will tell you. A 5 kg body moving with 10 meter per second velocity in x-axis direction. Okay, na? And same 5 kg body, after some time its velocity becomes 15 meter per second. How much its velocity becomes? Its velocity becomes 15 meter per second. Okay, na? How much its velocity become here? 15 meter per second. Understood here? So in this situation, if you go for the final, this is the initial momentum now. 5 into 10 is the initial momentum. Initial momentum how much you got? 50. This is the final momentum. 5 into 15. I get as 75. 55, 75. Right, this is the final momentum. Got it now? So what I am asking here, I am asking to find the change in momentum. Change in momentum is what? Final momentum minus initial momentum. Final momentum how much? 75. Initial momentum how much? 50. So finally the change in momentum how much I got? 25. Change in momentum is 25. What are the units for this? The units commonly get as kg meter per second. Just hyphen here, kg meter per second. Okay, na? So this is in this way. A body of mass 5 kg moving with a velocity of 10 meters per second. After some time, its velocity becomes 15. So what is the change in linear momentum? Change in linear momentum. In this way, you have to simplify it. This type of models we have here. Why I am saying these problems here, try to do the solve the problems and it makes you a lot of help. Okay, na? It helps a lot in future after joining here. Okay, na? Try to how to solve the problems. That's what I'm discussing here. While doing some concept, while explaining some concept, I'm trying to solve some problems here, which are possible. Easy models, very easy models, I'm commonly discussing here, right? Very easy models I'm discussing here. Just many of you have to get how to solve these problems first of all. Okay, na? So this is the changing linear momentum. Okay. So in this way, let us see one more problem here. Be careful here, right? I'm taking a 5 kg body. Let's take it 7 kg body. Okay, moving with some velocity. Moving with some velocity is given as some 5 meter per second. Moving with velocity 5 meter per second. Okay, na? Right. Now what happened here is here one wall is there. What's it called? Wall. A ball, let's say a ball of 7 kg. 7 kg not possible. Let's take 1 kg, no problem. Okay, na? Let's take 1 kg. Okay, going with a 1 kg ball, moving with a velocity v 5 meter per second, and collides the wall. Collide means hit it. Okay, when you throw a ball onto the wall, what happens? Again, it rebounds back here. Let's say rubber ball. Okay, na? Rubber ball. Okay, let's consider this 1 kg hit this wall here. And again, after hitting the ball starts coming back. Correct? Understood here? A ball you throw onto the wall here, it will rebound to the same speed. Let's see, same speed, okay? It comes back with the same speed. When it comes back with the same speed, means initial hitting speed is 5 now. After hitting the wall, what is the speed? 5. After hitting the wall, 5, let it be, no worry. Let it be 5. Different, take it, no problem. You take it different. So how it comes with the same speed? Take it as same speed, or a different speed, take different, no problem for us, okay? Okay, fine. Let us take it. First we'll take it as a same speed, okay? Fine. Now what is the changing momentum during this? During this, what is the changing momentum? First I will write the initial momentum. What is the initial momentum? Initial momentum means that before hitting the wall. Before hitting the wall, what is the momentum? Mass into velocity. Mass into velocity. What is the mass? 1 kg. Mass how much? 1 kg. Okay, na? Understood here? Mass is 1 kg. Okay, fine. What is the velocity? 5. So total how much you get? Velocity is 5 meter, 5 kg. Sorry here. Momentum how much you get? 5. Tell me. 5 kg meter per second. How much you get? 5 kg per meter. Got it here? 5 kg per meter. Okay, na? 5 kg meter per second. Okay, fine, right here. So that is that. After hitting the wall, after rebounds, after hitting the wall, the ball comes back. Okay, after hitting the ball comes back. Okay, comes back. What is the momentum? Mass into velocity. What is it? Mass into velocity. Okay, na? Okay, na? So what is the mass? 1. What is the velocity after hitting the wall? After hitting the wall, what is the velocity? After hitting the wall, what is the velocity? I am writing it as a 5. Is it right or wrong? Tell me. Is it right or wrong? Okay, I am writing this one as a 5. After hitting the wall, the speed of the ball, the velocity of the ball is 5. Simply I am saying. Is it right or wrong? So it's a wrong here. Why? Because I have to write minus 5. Why I have to write minus 5 here? Tell me here. Why I have to write the minus 5 here? This minus 5 represents the body is coming in this direction. Previously, this body is moving along positive x-axis. Before hitting the wall, the body is moving towards the in positive x-axis direction. Correct, na? Good, opposite direction. Good. Okay, u is moving in this direction. Okay, na? Got it? U is equal to 5. In this direction is moving. Whereas after hitting the wall, the speed is velocity is in this direction. Opposite direction, negative x-axis. This is negative x-axis. Commonly we will take, correct? See, this is x-axis, y-axis, and this is the origin. This is positive x-axis, and this direction is negative x-axis. Correct? This is negative x-axis. This is positive y-axis, and this is negative y-axis. Correct? Now, so if you observe in this situation here, in this case, if you observe, I can simply say that. Yeah, fine. This is why I am taking minus, because after hitting the ball is moving in this direction. That's why I am taking this one as a minus. So I am getting this one as how much I am getting? Minus 5 kg meter per second. Minus 5 kg meter per second. Got it here? Minus 5 kg per meter per second. Kg meter per second. Okay, na? Now my task is actually to find the changing momentum. Changing momentum means I can write this one as final momentum minus initial momentum. Correct? Final momentum minus initial momentum. What is final momentum? Minus 5. Minus initial momentum. Initial momentum how much? 5. So how much you got here? Minus 10 is the answer. Got it? Minus 10 is the answer. Understood here? The change in linear momentum is minus 10. What is it? Change in linear momentum is minus 10. Got it here? Understood? If you didn't consider the minus, what happens here? See here, if you didn't consider the minus here you are just simply neglecting the direction which consider. If you didn't consider the direction, what happens? Here you will get plus 5 here. Correct? Plus 5. Correct na? What you get then? Changing momentum. Then changing momentum I will get as a okay. Final momentum is 5 minus initial momentum is 5. How much are you getting that? 0. In the options of this question, 1, 2, 3, 4 options, multiple choice questions we commonly have here. We'll have one option as 0, another option will have the minus n, another option will have the 10. So among these, which is right, we must be careful. Because linear momentum is a vector quantity, we have to consider direction. 100% direction should be considered. Okay, na? Direction should be considered because it's a linear momentum. Okay, na? Got it here? So now what I am going to do is one more time I will try to recollect it what we discussed. Okay, small definition we have studied here. The small definition which we are studying here is linear momentum. Linear momentum is mass into velocity. Correct? Units kg meter per second, leave it. The problem which I am saying is the same one I am repeating one more time. See here. A ball of mass m moving with a velocity v collides the wall and rebounds with the same speed. Rebounds with the same speed. In this case, what is a change in momentum? Simple question. What is it? In this situation, what is a change in momentum? Let us see here. Change means initial momentum. Sorry, initial momentum, m into, I can write the initial momentum as m into vm. How much more? Initial momentum is m into v. What is the final momentum? Final momentum is m into minus v. Why I am taking this as minus v? Tell me here. Why I am taking as minus v here? So is equal to, we can write as a minus m into vm. What is final momentum? Minus m into v. Understood? So the change in momentum is equal to how much I can write? Final momentum minus initial momentum. Final momentum minus initial momentum. Correct? What is final momentum? I got minus mv. Have you understand why I am writing minus here? Because the velocity is in negative x direction. I have to represent the direction also. Because the linear momentum is a vector quantity. Okay na? Fine. Minus initial momentum mv. So final how much you got? Minus 2mv is the change in linear momentum. Understood it? Is the change in linear momentum. Got it? Is a change in linear momentum. Good concept, good point you get understand here. Momentum, change in linear momentum. Okay na? Fine? Right here. Here, okay na? So what is the minus represents here? Minus represents along negative x-axis. Change in linear momentum is along negative x-axis. Change in linear momentum is along negative x-axis. Remember that point. Okay, here we got the minus or minus represents direction itself. Direction itself. Understood here? Okay na? Got it? In this way we have to try to simplify here. Okay, fine. This is the one example which we can go for this. Okay, we have many examples here, but before seeing that examples, we have to know some resolving of the vectors. What is it? Resolving of the vectors. Actually, we have some discuss in a basic bridge courses somewhere. We discussed much about bridge vectors. Okay. So once if you know the resolving the vectors, you can see some more here. So what I will do now is, okay, we'll see that examples in tomorrow class. Now I will try to resolve how to resolve the vector. Simple I'll tell you. Vector. Vector means how remember what is a vector? Vector means a vector which is having the both a physical quantity which is having the both magnitude, direction, and it should obey the laws of vector addition. Okay, just I am taking a vector here, simply take it a vector. I am naming this vector as a bar. A bar. Correct? A bar. So for simplification here, for simplifications, let's consider if some vector is in this direction, I can simply say B bar is along x-axis. B bar is along x-axis. Simply I can say along x-axis. B bar is along x-axis. Simply I can say what about A bar? How can we get in which direction it was? Correct? We cannot give the exact direction of this here. So further, what I am doing is how much angle it was making with the x-axis I am calculating. Let's consider the angle which it was making is theta with the x-axis. How much angle? Very important here. Resolving the vectors is much important. Careful. Okay. This A is making an angle theta with the horizontal. A is making an angle theta with the horizontal. Okay. Let's consider x-axis with x-axis. Okay. So what I am doing is I am trying to form a right angle triangle. See, this is y-axis. What I am doing is I am dividing this A into two parts. I am dividing the A into two parts. Remember carefully. Okay, now I am dividing this A into two parts here. Understood here? I am dividing this A into two parts. One is this one and the one is this one. If you observe here, these two are perpendicular. See, these two are perpendicular. See, this A is divided into two parts. These two are perpendicular, compulsory perpendicular. No doubt. 100% they must be perpendicular. No doubt at all. Okay, na? 100% these two x and y must be perpendicular. No doubt at all. 100% x and y must be perpendicular. Listen carefully. Okay, na? This is A. Now I am dividing this A into two components. Okay. So for that what I am doing here is, okay, na? So you can see if this is y, this is also. Okay, na? See, okay, I will try to write out. See here, I can form a right angle triangle here. Okay, na? Got it here? Right angle triangle. From this right angle triangle, can you tell me what is cos theta? I think cos theta is nothing but adjacent side by hypotenuse side. Adjacent side by hypotenuse, right? What is adjacent side? This one. I am naming this one as AX. Why I am writing AX is it is along x-axis. What is it? Along x-axis. AX. By what is hypotenuse? This is hypotenuse. From here, tell me what is AX. Bring this A cos theta here. A cos theta is equal to AX. So I can write the AX as A cos theta. AX is A cos theta. Understood here? AX is A cos theta. Okay? Fine. In the same way, from this same right angle triangle, what is sin theta? What is sin theta? Sin theta means opposite side is this. I will name this one as A. This is nothing but this one itself. See, same. I am taking the same here. Okay? Fine. Sin theta is equal to opposite side by hypotenuse. Opposite side by hypotenuse. Understood here? Opposite side by hypotenuse. What is opposite side? Opposite side is A by. Okay? What is hypotenuse here? A. Hypotenuse is A. So AY is equal to how much you can tell me here? AY is equal to A sin theta. Got it here? Understood here? Listen here. This vector A can be resolved, nothing but divided into two components. One is A cos theta and the one is A sin theta. Understood here? Okay? Na? A vector can be divided into two components. Much important this is. Throughout the physics of the 2 years, much important. Okay? So this is a vector can be resolved into two components. Ax and the one is Ay. Ax is A cos theta. Ay is A sin theta. Okay? Ax can be resolved as A cos theta, whereas Ay can be resolved as A sin theta. Means A can be resolved into two components, Ax and Ay. Ax means it is along x-axis. Ay means along y-axis. Means I can simply say, if anywhere if I find a vector like this, I can write this one as A cos theta, where this angle is theta. If I can take this one as A sin theta. Got it here? Okay na? So resolving the vectors here. Okay? So in this way I can resolve. And I can write finally, A can be written as a vector. A bar is equal to Ax. Ax in which direction? Along x-axis. I represents along x-axis. Along x-axis. Ay, j cap. Ay is along y-axis. It is along y-axis, j cap. Okay na? What is the magnitude of this one? Root of ax square plus ay square. What's it? Ax square plus ay square. Okay na? Let's see here. What is ax square from here? Tell me here. Ax square right here. Ax square is equal to a square cos square theta. Similarly, tell me ay square is equal to a square sin square theta. Correct? Ax square is a square cos square theta. Ay square is a square sin square theta. Correct? Just add these two once. Once you add these two, ax square plus ay square. Add these two. Ax square plus ay square is equal to, add it, a square cos square theta plus a square sin square theta. Correct? A square cos square theta plus a square sin square theta. Correct? Now you do one thing. Just here take a square common. Just there take a square common here. Okay na? Just take a square common here. What you get here? Okay, I write one step here. Take a square common. Take a square common, what you get? Cos square theta plus sin square theta. Correct? So cos square theta plus sin square theta 1. So it's equal to a square. Okay? So anyway, once again I will try to revise this. Okay na? I will try to revise this concept again in tomorrow class here. Okay na? But today again I will try to revise this one more time. Okay? Just follow this. Just these are the basic concepts which we are discussing here. Remember that point. These are the basic concepts which we are discussing. That's all. Okay? Just basic concepts only we are discussing here. Try to do not neglect it here. Just try half an hour. I will take maximum half an hour. More than that not possible. Okay? Half an hour. Just spend this half an hour. It will be helpful in future. Okay? Right. Bye. Thank you. Thank you. Bye.